Okay, this is trigonometry, the text section 1.5s. You can see the objectives there to be able to use the calculator to evaluate some trigonomic and inverse trigonometric values. We're doing page one only of this section. We'll do page two another time. This will be a long enough video just to do all the way to 2i down here. Should have a calculator of some type as well. Remember to put it in degree mode. And we'll go from there. All right, so let's try the first. This is just boilerplate stuff. So go ahead and just write that out. I really don't like how he did that exactly, but this means inverse, the inverse. And I'll explain all this. I don't think this is going to help a whole lot. I probably should change that. It's not great. But just kind of get that written out. I won't even really refer to it. But all right, so when you have a question like this right here, the cosine of 205 degrees. First of all, we're a little bit ahead here. You got to start thinking about cosine is x, and 200, you should know 206 degrees is right about here, okay? So just to give a little bit of a longer explanation, because we're just taking baby steps here. So 206 degrees, and cosine is the x. So on this side where the arrow is, in quadrant 2 and quadrant 3, quadrant 2 and quadrant 3, the cosine or x is negative. So just so you know that that's going to happen, you should know that. The maximum cosine can be is 1 or -1, and then the minimum is, a decimal. Okay? So let's go ahead, and with that in mind, let's go ahead and jump into the calculator and get this done. I mean, you may not even care about all that I just explained. You still want to get the answer right, which is fine. Cosine of 206.5 degrees. Clear that. The cosine, before I do that, go to, go to mode. Make sure it's in degree mode. Degree is right here where the cursor is. Make sure you're in degree mode. All right. Second quit, that's the home screen. Cosine of 206.5. All right. And then you'll get that the answer of negative 0.895, however you want to round. Okay, so there's that one. Easy. Okay. Tangent, by the way, can be a huge number. Tangent is y over x. Okay. It's sine over cosine. It's also slope. Tangent is slope in statistics. Okay, so in this particular case, because this doesn't have radian, it doesn't have degree, there's no degree symbol, this is actually in radians. And we're going to explain later what radians is in detail. But for right now, degrees is how much of the 360 degrees is taken up. Radians is the length of the arc that the degree takes up. I'll explain more of it later. But if you don't see degrees, and notice you do not see degrees here, it's going to be radians. So you got to go into your calculator and make sure you go, clear that, go mode, and then go down to radian. Hit enter. Now you're in radians. Okay. Second quit. I kind of forget what the question was now. Tangent of 1.892. Okay. So I'm going to go the tangent. And again, I'm in radians. 1.892. Okay. There you go. Negative 3.005. Nobody thinks in radians that I know. Everyone thinks, unless you're really smart, everybody thinks in degrees. So this is going to be later on. This is a little out of order, but later on, just the way the book is, later on, we'll do a better job explaining all that. But for right now, we're just going to get you some basic skills, okay? All right. Cosecant of 38 degrees, okay? So this is the inverse of sine, and again, it's degrees. So I need to go to the calculator and go to mode and change it to degrees. Hit enter right there, change it to degrees, okay? Second quit. And then I'm going to go 1 divided by the sine, and I forgot what the question was, Sine of 38 degrees. 1 divided by the sine of 38 degrees. Okay, there we go. 1.624. Okay, 1.624. All right, great. Okay. And this depends on how you're using your calculator. All right, this one's a little tricky. We're going backwards now. This time we're going backwards. What we're saying is instead of having an angle, and a radian is an angle, basically it's it's the length of the arc, but it's referring to an angle. This is the reverse. This says what angle has a sine of radical 3/2. Now, eventually you're going to memorize this. I'm going to give you a super good skills on it, but we're early on in the course. So it's really simple here. So I'm just going to punch it in the calculator. If you notice there's two answers, and I'm going to explain that in a second, and this could be confusing for you. This could be the hardest part of this lesson. Okay, so let's go ahead and go to our calculator, all right? And I'm going to leave it in degree mode, and I'm going to go second sine, okay? And that's the inverse. And I'm asking what angle has a sine of radical, where is the radical? Second, there it is, radical 3. Make up a space here, space, divided by 2. There we go. You have to play with whatever calculator you're using. And it's going to give me, it's always going to give you, or often going to give you the first quadrant answer. So let me explain this. Okay, notice it's 60 degrees, the answer, but it's not the only answer. And this is the most commonly missed question on the Chapter 1 test. And again, we're early on. We'll learn this better later. Okay, so right here, 60 degrees, okay, and sine is y. So the length of, there we go. The length of that is radical 3/2, which is like 0.86. Remember, the maximum is 1. Now, the sine is positive in the first quadrant, 1, because it's y, and in the second quadrant here as well. So you have to ask yourself, what other angle is the exact same as this in the second quadrant? I'm going to draw an identical one. I didn't do a very good job. This one right here, right there we go. An identical one there. So that's 60 and 60, 120. Now, I wouldn't worry about these answers, pi/3 and 2 pi/3. That really comes later when we start talking in radians. This is the tough one for kids to get. Hopefully you understood that. Okay. Let's go to the next one. Okay. So the cotangent, which is the inverse of tangent, negative radical 3. Okay. So I'm going to do the inverse of this, okay? So I'm going to go, let's see here, cotangent negative radical 3. So I'm going to go second tangent of 1 divided by negative radical 3. And then I'm going to close parentheses. And you get negative 30 degrees. Okay. Negative 30 degrees is actually 330 if you think about it. Okay. So that's negative. It's negative 30 degrees is 330. So let's look at this. Okay. So here is negative 30 or 330 degrees. Okay. Now the tangent is negative in the first quadrant, is negative in the fourth quadrant down here. And it's also negative in the second quadrant. And the reason is because tangent or cotangent is y over x or x over y. So if they're both positive, like in quadrant 1, then the tangent or the cotangent will be positive. Or when the sine and the cosine are both negative, then it's also going to be positive. So you got to ask yourself, is there an identical angle right here. It's a reference angle. Notice it. Notice this is 30 degrees in this way. I'm going to go 30 degrees in this way. So that's going to make it 150 and 330. And again, don't worry about this. I think these are difficult. These are a struggle for kids. Okay. And if you need further clarification, I will give it to you. Okay. But those are the ones that kids have a tendency to miss, I think, on test day. Again, the chapter one, none of this is hard, but they have a tendency to miss that. All right. This is a radian one. This is a radian. So, and you can tell it's radians. Well, actually, I'm going to leave it like that, 5.7. It's not, I'm going to make it degrees. Okay. Which is fine. So secant some angle is 5.7. All right. So I'm going to go, let's see here. Second, I forgot what it was. Second, let's secant, so it's cosine. Second cosine 1 divided by 5.7. And notice it gives me about 80 degrees. I'll just go with 80. Okay. We're going to look for the other angle here, though. So let's say this is 80 degrees. Excuse me. This is 80 degrees. All right. So there's 80 right there. Okay. And you got to ask yourself, where is the secant or the cosine positive? X is positive in the first quadrant, where it's at right now, and in the fourth, in 1 and in 4, right here. Okay. So I'm going to go 80 degrees from the reference angle from here into this degrees. And that's going to be about 280 because I go around, it's about 280, or 360 minus 80. Okay. And that's where you get two answers, 80 and about 280. Okay. Those are tough. Those are not easy. Those are the hardest ones. And you may need additional support on that. And I'm happy to give it to you. Okay. All right. Now, let's go down to the next ones. Okay. Sketch the triangle if necessary. We are doing the Pythagorean theorem. No problem on this. This is not hard. Okay, so we got a right triangle. Let's do this. Are you ready? I'm going to draw it out. Oops. Probably not drawn to scale. Let's say B is 48 degrees, 48. And so that'll make this B. Remember, the name for the sides is lowercase. The name for the angle is uppercase. And then the side is opposite the angle. So if 48 degrees is here, then opposite of that, looking at it, is B. And then A is 11, so that's going to be this one right here. Okay. And this is a 90-degree angle. And then, of course, this is C. Okay. Now, go ahead and fill this in. Well, I think it's pretty easy to get 42 degrees. You're just going to go 48 minus 42. That's no problem at all. Now, how are we going to get B, this side right here? Okay, one way to do it is to use the existing angle, and we're going to go the tangent of, I'm going to go tangent of 48 equals the opposite, which is B, divided by the adjacent, which is 11. Okay. So basically, that formula that you know what tangent is, opposite over adjacent, all you have to really do is go the tangent of 48 times 11. You'll get it. Okay. So remember that. I'll leave it up here so we can see it. Clear this. Tangent of 48 times 11. And you get about 12.2. The nearest tenth is fine, 12.2, which you can see right there. Now, if this is 12.2, how do you get C? There's a lot of ways to get C. You could do the Pythagorean theorem. You could. You could also do a sine, because this is 42 degrees. You could do a sine or a cosine function. It doesn't matter. I'm just do a sine one. I'm going to do the sine of 42 degrees equals the opposite 11 over the hypotenuse, which is C. Okay. I'm going to switch these using simple math. And so C is going to equal 11 divided by the sine of 42. You probably did this stuff in geometry. That's my guess. So 11 divided by the sine of 42. Okay, let's bring that up. So 11 divided by the sine of 42. 16.4 or so. Perfect. 16.4. All right. And there you go. Okay, so let me erase that. Let's do another one. Little bit of work. It's a little time consuming because you got like 6 problems in one, which is kind of annoying. But or I guess it's 3 problems. Why shouldn't I say 6? But now let's do this one. Question B here. The right triangle, angle A. So here we go. I'm going to draw it out. I won't draw it to scale, but good enough. 62 degrees. That's A. And A is 19. Okay. So we do know that this is 28. That's going to be easy to figure out, 28. The reason we know that is we're going to go 90 minus 62, which is 28. No problem. Now we got to get C and we got to get B. You have options. I'm going to choose, let's see here. I'll do tangent. I'll do the tangent of 28 degrees. The tangent of 28 degrees, you have other choices to do. This is only one way, equals the opposite B over the adjacent. Okay, opposite over adjacent. So I'm just going to go the tangent of 28 times 19, and I should get B. All right. The tangent of 28 enter times 19. Get about 10.1. Okay. As you can see right there, 10.1 for B. Now for C, you got options, but I'm gonna do, let's see here. I will do, let's see here. I will do the cosine. No, I'll do this. I'll do the sine. I'll do the sine of 62 degrees equals the opposite 19 over the hypotenuse, which is C. Now, using simple math, I'm going to switch these two. So C is going to equal 19, because you can always switch them diagonally. 19 divided by the sine of 62. Okay. So C is going to equal the sine. C is going to be the equal to 19 divided by the sine of 62. All right. So I'm going to go 19 divided by the sine of 62. 21.5 or so. Okay. So we are good to go on that one. So that's B. So that B is done. Now these are all pretty similar. Remember, there's multiple ways of doing these. And I am making the assumption that you've seen this in geometry before. This is not something that's new to you. Okay. So question C now. Question C. Okay, so we got, let's see here. We got A, I'll put A here. A is 11, C is 16. and we don't know what B is. Okay. So there's a couple of ways to do, B. One way to do B is just do the Pythagorean theorem. You could, which will be 16 squared equals 11 squared plus, by the way, this is a right angle, plus B squared. You could do that. So 16 squared minus 11 squared square rooted. Okay, basically. Let's try that. So I'm going to go 16 squared minus 11 squared. Then so it's radical 135. So second square root. Whoops, that's not what I'm trying to do. I'm going to go second square root of 135. There we go. About 11.6. Okay. So that's about 11.6. And let me write that down. Well, you have it written down anyways, but 11.6. You can see that right there. Now, how do you get these angles? A bunch of ways. I'm going to stick with the numbers 16 and 11. Let me just pick this angle. So this angle, if I'm using 11 and 16, this will be the cosine, adjacent over hypotenuse. So the cosine of some angle, and we practice this up above, equals 11 divided by 16. Cosine of some angle is 11 divided by 16. Okay. All right, so here we go. Let's try. I'm going to go second cosine because I want the angle. 11 divided by 16. I'll just rant. Well, I'll see where it comes out. 46 degrees, 47. Let's just say it's 47 to make it simple. 47 degrees. I probably wrote the exact number out here. Yeah, let's just say it's 47. So if this is 47 degrees right here, okay, then this will be about 43. I'm just going 90 minus 47. I don't need to do another calculator function with the inverse of sine or cosine or tangent. It doesn't make any difference. You can use the 90 minus rule. Okay. All right. So there's 2C. We've got a few more to do here. Okay, so we got 2D, E, and F. And again, these are very lengthy, but let's attack them here. We'll get really good at this. All right, so A is 23 degrees, so A is rather slender. Make this 23 degrees. C is 9 right there, okay? That's terrible 9. Now, we got, so this is side A, again, lowercase, and this is side B. I really want to erase this. Okay, try again. Oops. This is a 9, there we go. Now, so we can get 67 degrees very, very easily. Just go 90 minus 23. That's easy. Don't even bother with that. So won't even bother with that. Now let's get side A. Side A should be the sine of 23 degrees should equal A opposite over hypotenuse, which is 9. So all I'm really doing is going the sine of 23 degrees times 9. Sine of 23 times 9. Here we go. Clear this. Sine of 23, enter, times 9. And you get about 3.5. That's good enough, 3.5. I don't really have rounding rules for you guys. Now, so you got that, 3.5, that's there. Now, how do we get B? We got a lot of options, but what I'm going to do is I'm going to do the cosine of 23. You do have other options, but I'm going to do the cosine of 23 degrees equals adjacent B divided by 9. So all I really have to do is a cosine of 23 times 9. Okay, cosine of 23 times 9. Here we go. Clear that. Cosine of 23 degrees, enter, times 9. 8.28. Sound good? It sounds great. Okay, so there's that. Okay, so this is getting repetitive. Hopefully you're trying to pick up on it. Getting very, very long one page, which I was splitting this into 2 days, which makes the most sense. All right, in the right triangle here. Here we go. Right triangle, A is 17, B is 23. So here we go. So A is a little shorter than B, 17. It's A, 17, 23. It's really hard to write with a cursor with a mouse. And this is C. Okay. So you could use the Pythagorean theorem if you wanted to. I did it before. Did I skip B? I mean, I skipped E, huh? Let me get to E. Let me backtrack on that. I did not do E. Let me do that. Here is E. Okay. A is 50 degrees. 50 degrees. I'll make this A. And B is 32. The length is 32. So here's A. And here's C. So we know this is 40. No problem. That's 90 minus 50. Now, let's figure out a couple of ways to make it real simple to get the length of A and the length of C. Let's try the tangent. You don't have to do tangent. You could use other ones. I'm going to go the tangent of 50 degrees equals opposite, which is A, divided by adjacent, which is 32. So really all I'm doing is going the tangent of 50 times 32. Okay, tangent of 50 times 32. Let's do it. Tangent of 50, enter, times 32. About 38. Okay, about 38. All right. Now, to get C, I'm going to go, again, you have options. To get C, I am going to go, let's see here. I'll go the cosine of 50 degrees equals the adjacent 32 over the hypotenuse, which is C. And remember, you're always allowed to switch diagonally. So that really means C equals 32 divided by the cosine of 50. That's easy. 32 divided by the cosine of 50. All right, let's try it. So we got 32 divided by the cosine of 50. About 50 or 49.7 or so. Okay. You can see the answers there. All right, so let's try the next one, which is item 2F. Okay, item 2F. We got a right triangle. I started this before and then I aborted it. Sorry about that. I went out of order. A is 17, B is 23. And we got C right here. You could use the Pythagorean theorem. I'm not going to. Let's start with this angle right here, which is angle A. Let's try this. So and we're going to use tangent. So for this, the inverse of tangent to the -1 should equal opposite 17 over adjacent 23. Sound good? So I'm going to do that, and I'm going to get the value of that angle. So here we go. So I'm going to go second tangent, 17, it's on my screen, divided by 23. About 36.5 degrees, somewhere there, 36.5 degrees. Let's just say 36 degrees. So That's A. So you can see the answer for if that's 36 degrees, then B will be around 54, which is 90 minus. So that's B right here. Okay. So this is about 36 degrees. Okay. Now, there's a lot of ways to get C. Pythagorean theorem is one of them. I probably should use the Pythagorean theorem because I rounded 36 and 54. And so I would get a slightly inaccurate answer. So I'm just going to go ahead and do that. That's going to be 36 squared plus 17 squared equals C squared. Okay. All right. So here we go. I'm going to go clear that. 36 squared plus 17 squared. Then I'm going to square root that. Second square root, where was that? Where's that? Second square root. Oops, that's not it. Second square root. Yeah, there we go. 1585. All right, there we go. About 39.8. 40 if you want it around. Okay. So, got that right? Oh, did I put the wrong numbers in? Well, I was looking at the angle. I'm such a fool. Okay, let me go back. Let me go back on this. I am so sorry. Let me erase this. Wish I could erase it from the video, but anyhow. All right, try that again. It's gonna be 17 squared plus 23 squared equals C squared. I got the angle number in there. I'm such a fool. 17 squared plus 23 squared square root. Let's try that again. This is live. So we got 17 squared plus 23 squared. We're going to square root that. Second square root of 818. Sorry about that. 28.6. Hopefully you forgive me. All right. Let's try this again here. All right, now G, H, and I are actually a little bit easier. They will only want one answer, which is kind of cool. So let's try it. Let's move this up a little bit so you can see it better. There we go. And then we're going to do this from 3 down on another day. It's a very long video. Okay, so isosceles triangle. Remember what isosceles means? Isosceles means two sides are equal. Let me try to get this right. There we go. So these two sides are equal. Okay. And the base angles are 37 degrees. So that's 37. And of course, that means that one's 37. Okay. They want the altitude. The altitude is a drop on 90 degree right there. Okay. So what you have, you can see it right here. Oh, by the way, the base length is 16, meaning half of it's 8. Both halves are 8. So you can see what you really have here is a right triangle. I'll redraw it. That's 8. That's 37. And we're looking for X right there, the altitude. So that's going to be the tangent of 37. Tangent of 37 equals X over 8. Now, I will not punch in the calculator. I'm assuming at this point you can do it. Okay, so that's pretty simple. Okay, so let me erase that. All right. Now, the next one, isosceles triangle. Again, isosceles triangle, I will draw as best I can. Okay, so these two sides are equal here and here. Base angle is 40. So that's 40 right there. And this is 40 right there. Base length is 7. So that means this is 3.5. And so is the other one. Okay, 3.5. So I'm trying to find this. I'll call that x. So in this case, it's going to be a cosine deal. Cosine of 40 is adjacent 3.5 divided by the hypotenuse, which is x. So when you do this, let me draw this out a little further. I won't punch in the calculator, but cosine of 40 equals 3.5 over x. Remember, you can switch them diagonally. So x, what you're looking for, will be 3.5 over the cosine of 40. Okay, sound good? I will. That's great. I'll leave that alone then. And the last one's going to be similar. Okay, get all these erased here. Okay, last one. Altitude is 20. All right, so let me draw the isosceles triangle. Altitude is 20. So this right here is 20. Okay. Base length is 36. That means this is 18 and this is 18. Find the base angle right there. So this angle, tangent of x, will be the tangent of some angle will be the opposite 20 over 18. You see that right here. So you're going to type this in your calculator. I'll do this one for you. The inverse. Okay. So let's get over to that. So we're going to go the second tangent, 20 divided by 18 is going to give me an angle. Okay. About 48 degrees. Okay. That is your support vehicle for trigonometry section 1.5, just the first page. In case you're absent or I'm absent, it's something to support you with your notes. Thank you very much. Take care.